Welcome to Dr. Scott's Maths Made Simple, Speed, Time and Distance. Let me start by giving you some words of wisdom. Many people spend their lives trying to acquire a trophy house or a trophy car or a trophy husband or a trophy wife. Well, I've followed suit. I have actually acquired a trophy toothbrush. Look carefully. My neighbours are envious. Yes, that's my trophy toothbrush. It's the talk of the town. Okay, enough of that. All right. Distance equals velocity multiplied by time. Velocity is speed. Same thing. V for velocity. Distance equals velocity times time. If you know this formula, you can work out everything else. You can work out the distance if you know the velocity and the time. You can work out the time if you know the velocity and the distance. And you can work out the velocity if you know the time and the distance. So if you know two of them, you can work out the third one. For example, if we wanted to work out what time it took for something to travel a certain distance at a certain velocity, time, just divide both sides by V equals D over V. If we wanted to work out how fast something was going and we knew the distance and time, we divide both sides by T. So velocity equals D distance divided by time. So if you just remember one formula, D equals VT or T equals D on V, I suggest you pick one without a division sign in it. D equals V times T, you can work out everything else. Let me show you how interesting this is. Say someone was traveling at, say 30 kilometers an hour. Per hour, and they're going for half an hour. So half an hour is 0.5 hours. So how far, if someone's doing 30 kilometers an hour in a car and they travel for half an hour, you probably know they're going to go 15 kilometers, so half of that. But this is how you actually work it out. So the distance traveled equals 30 times 0.5, which is 15 kilometers. The hours cross out because this one's on the top, this one's on the bottom. You see, it's per hour. So that one's on the bottom, that one's on the top. So they cross out, you end up with kilometers. Providing you keep the units in the same in whatever you're doing, everything's okay. You can use meters, seconds, hours, days. You just got to keep everything the same in the calculation that you're doing. So if someone's doing 30 kilometers an hour for half an hour, they'll travel 15 kilometers. The other day, I met Terry the turtle, and Terry was talking to me, and Terry said, Dr. Scott, I can travel 200 meters, but it takes me 100 seconds. So, Dr. Scott, can you figure out how fast I'm going? Can you figure out my velocity? That's what Terry the turtle said to me. So I said, okay, Terry, well, your velocity equals distance divided by time. You said you travel 200 meters and it takes you 100 seconds. To do that. So Terry, 200 divided by 100, we can actually cross the zeros out if you wanted to make it easier. 200 divided by 100 equals 2 meters per second because it's on the bottom. So Terry, you're traveling at 2 meters per second, which I don't know the stats on turtles, but actually you're probably doing pretty well. Good for you. Okay, so Terry was traveling at 2 meters per second. Okay, all right. You say, I've got a long road trip coming up. I've got to travel 400 kilometers. And the speed limit, the fastest I can go is 100 kilometers per hour. Well, how long is it going to take me? Well, we know from this formula, t equals distance divided by velocity. So 400 kilometers is the distance. The velocity is 100 kilometers an hour. Divided by 100 kilometers per hour. 400 divided by 100 equals 4. You notice the kilometers cross out and you're left with hours. So that will take 4 hours. And it makes sense. If you've got a 400 kilometre trip, you're doing 100 kilometres an hour, it'll take you 4 hours. You have to excuse Doggy. Doggy's hungry. They say don't work with animals or children. I don't know about that. All right, so another question to pose for you. If I shone a torch at the moon, how long would it take the light to get to the moon? Well, the distance, so we're after time. How long would it take? The distance to the moon at the moment is about 405,000 kilometres. Interesting, eh? And the velocity of light is 300,000 kilometres per second. Pretty jolly fast, the old light. So, how long does it take my torchlight to get to the moon? Well, T equals D on V. So the distance travelled over the velocity, which equals 405,000 kilometres over 300,000 kilometres per second, which equals 1.35 seconds, which isn't very long, is it? Light is terribly fast, as Einstein once said, or words that are similar. What about if we want to work out, just quickly, how fast does Usain Bolt run? We know, I think he's the fastest person in the world, am I correct? And I think he does the 100 metres in about 9.7 seconds. So what's his velocity? How fast is he running? Well, the distance he's running is 100 metres. I think we all agree on that. That's like that. And the time he takes to do that is a bit quicker than me, 9.7 seconds. So what is his velocity? Well, velocity equals distance divided by time. So velocity equals distance over time, which equals 100 metres over, the time is 9.7 seconds, which equals, if you work it out on the calculator, that's 10.3 metres per second. That's how fast he's running. Well, that's pretty jolly fast. But say that doesn't mean a lot to me. I say, well, tell me, Dr. Scott, what is it in kilometres per hour? Well, let's do it in metres per hour for a start. So the number of seconds in an hour is 60 times 60. Would you agree? 60, poor old pen's getting slack. 60 seconds in a minute times 60 minutes in an hour, which equals 3,600 seconds in an hour. Okay, so 3,600 seconds in an hour. So this would equal, if we multiply this by 3,600, we get the metres per second. And then if we want the kilometres, we divide by 1,000. And what we end up with is 37, approximately, kilometres per hour. Because when you multiply 10.3 by 3,600, you get 37,000 480 meters per second, which is 37,000 meters per hour, sorry. So there are 1,000 meters in a kilometer. So this is approximately 37,000 meters, which is 37 kilometers in an hour, just by multiplying by 3,600. So we worked out meters per hour, and then we changed it into kilometers. If you want miles per hour, if your country, they do things in miles per hour, you multiply to convert kilometers per hour to miles per hour, you multiply by approximately 5/8. If we do that with this, we end up with about approximately 23 miles per hour. So that's how fast Usain Bolt runs when he does the 100 meters. It's about 37 kilometers an hour, which is pretty jolly quick. I think a Belgian Shepherd can run at 64 kilometers per hour. That's my doggy. A cheetah, I don't own any cheetahs, but apparently they can do about 110 kilometers per hour. And that's the end of the lesson. So it's just distance equals velocity multiplied by time. I'll tell you something I always find amusing. We have the Earth and we have the Moon. No one can adequately explain to me how the Moon got there. Because the Moon is comparable to the mass or the size of the Earth. It's much closer to the size of the Earth than any other moon to any other planet in our solar system. Most of the other planets, or all the other planets have moons, but say you took Mars might be here, but it's got a couple of moons, but they're tiny, they're really small compared to the size of the planet. And you can explain that, but no one can explain why the moon is there. And I said to you, the moon today is 405,000 kilometers from the Earth. The reason I said that was it's not a complete circle around the Earth. It actually is an ellipse. So if that's the Earth there, if that's Earth, this is the Moon. It doesn't go in a complete circle. It's a bit elliptical. It's sort of like that. It's more like a football or an egg. And that's why the distance to the Earth, it varies. I'm exaggerating here how much, but it varies. The distance of the Moon from the Earth changes. The Moon is primarily responsible for the tides. The Sun contributes. When the Sun and Moon contribute together, you get a king tide. That's enough of me. I hope you found it helpful and interesting. And if you wish to like and subscribe, that'd be great. Thank you.